In this video, we're still going to be solving log equations, but in this video, we're going to be using properties of logs. We haven't really talked about many properties of logs, but we're going to introduce them here. The types of log equations that you've done before are the ones when you see a log on both sides of the equal sign, and on each side of the equal sign, the base of the log is the same. And you may remember that when you don't see a base listed, when you see log with no base listed, we understand that that's a common logarithm, and that's implied that that is a base of 10. So we have a base 10 log on both sides. That means that we would equate what we're taking the log of. So we've called it an answer, we've called it an argument. Nevertheless, n squared plus 6 is equal to 5n plus 2. And then we get a problem just like this one here, like number 2, where you get a log expression on one side, and then on the other side there's no log expression. And we said, well, look, if the variable is locked up in the log, like it is here, then we just convert to exponential form, and it makes it a much simpler equation to solve for. So we write the base 2 raised to the exponent of negative 1 is equal to x, and so x is equal to 1/2. So you see two types of equations that we've done before. This one here, number 3, we get 4 to the negative 2 equals n plus 2, and we can solve for n there. Here we get 6 to the first power is equal to 3r plus 2, and we can solve that for r there. It's a linear equation. And then something like number 5, where we can't convert this to exponential form yet unless we have the log on one side by itself equals a number on the other side. So all we have to do to take care of that, getting the log by itself on one side, is just subtract 4 from both sides, which would give us the log base 5 of 5 minus x is equal to 2. And then we can see again, we have our variable x locked up right here in the log expression, and to unlock that, we would just rewrite the same equation using exponential form. And so we would write 5 to the second power is equal to 5 minus x. And again, that's just another linear equation that we can easily solve using the same methods that we've used before. So similar to the first 5, where we have to get the log by itself, we would subtract 7 from both sides. We'd get negative 8. Multiply that by the log base 2 of x plus 4. And that's equal to negative 1 minus 7, which is negative 8. And in this case, we haven't really seen this before. We have a number out in front of the log, so we're going to go ahead and divide both sides by that number. And when we divide both sides by the negative 8, we get the log expression by itself. That's the key, is to get one log expression by itself on the left side of the equation. And then once we have that, we have a log expression on one side, no log on the other side. So we would, and notice that the variable is locked up in the log. So to unlock that, we would write it in exponential form, which then gives us a linear equation which we can easily solve. I'm going to go ahead and start the next video by doing number 7, which we can see we have something a little bit different. Actually, we don't. We don't have anything any different. 7 and 8 are exactly the same as number 6, so I'm going to leave those alone. And I'm going to actually, now we're going to look here at number 9. And number 9, we can see that's different. Finally, we have more than one log, and how are we going to handle that? So I'm going to talk about that in the next video, so we'll see you then.